This conference will now be recorded.
With your presentation 2.5 we will start this sessions, and 2.5 group number 1, please start presentation by 2.5, and then one by one I call and they need to present. So please inform your all friends to join by 2.5, and group number 1 please prepare to present. Yeah, group number 1, who want to present from group number 1?
Sir, Shubham Ghosh.
Shubham Ghosh. Yeah, I already make you presenter.
Yes, sir. Aman, please start.
Yes.
Okay.
Good.
You know how many name of the students who joined group number 1 is there? Aman Shah, present. Aman Shah.
Present, sir.
Then group number 1, Shoham Mitra.
Present, sir. Present.
Roham Mitra. Somo Chakraborty.
Yes, sir. Present.
Soumya Chakraborty. Toritra Banerjee.
Yes, sir. Present, sir.
Okay, so this students are in your group, right? Anyone left?
Yes, sir.
No, sir.
Okay. 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 So let's. So please start your presentation.
Yes,
Okay.
Aman.
Good afternoon. Good afternoon, sir. We, the students of Narula Institute of Technology of Electrical Engineering Department of session 2020 to 2024. We are group one. Our members are Aman Shah, Soham Mitra, Shubham Ghosh, Daritra Banerjee, and Soumya Chakraborty. We have prepared a Matlab project. The name of our project is Design and Implementation of DC to DC Buck Converter. So now my friend Soumya Chakraborty will explain the introduction of this topic.
Oh, thank you, Aman. So, what is a buck converter? A buck converter, uh, it is generally a step-down converter. It is used in power electronics, and we can say that it is a power electronics device. It generally steps down the voltage from input to the output. It is a class of switch mode power supply SMPS containing two semiconductors, diode, and transistor. Next slide, please. Okay, so it is called a buck converter. So why it is called a buck converter? Because because the voltage across the inductor, which is also called buck, it opposes the supply voltage. That's why it is called buck converter. Next slide. Okay, so it is having greater power efficiency than linear converter of about 90%, and it has various kinds of applications. Next slide. It is generally used in low power consumption or small electronic devices. It basically steps down from 24 or 12 volt to 5 volt, having a 95% efficiency. So now my friend Toritra Banerjee will continue.
Yes, sir. If we talk about the operation of the buck converter, the current in an inductor is controlled by two switches, usually a transistor and a diode. The switch and the diode have zero voltage drop when on and zero current flow when off, and the inductor has zero series resistance. The model of the buck converter is best understood if we understand the relation between current and voltage of the inductor. Now, if we look at the given circuit, when the switch is open, that is off state, the current in the circuit is zero. When the switch is first closed, that is on state, the current will begin to increase. Then the inductor will produce an opposing voltage across its terminals and in response to the changing current. The voltage drop that counteracts the voltage of the source and therefore it reduces the net voltage across the load. When the time passes, the rate of change of current decreases and the voltage across the inductor that also decreases. It causes increasing the voltage at the load. During this time, the inductor stores energy in the form of a magnetic field. Now, next slide. Now, this has several modes, that is continuous mode, discontinuous mode, and its conversion, that is discontinuous to continuous and continuous to discontinuous. Now, if we talk about continuous mode, the buck converter that operate in continuous mode, if the current through the inductor, that is IL, that never falls to zero during the commutation cycle. And in the discontinuous mode, if we talk about some case, the amount of energy that required by the load is too small. In that case, the current through the inductor falls to 0 during that part of the period. The only difference in the principle we have discussed is that the inductor is completely discharged at the end of that commutation cycle. Now, if we talk about conversion, the converter operates in discontinuous mode when low current is drawn by the load, and in continuous mode, that higher load current is absorbed. The limit between continuous and discontinuous mode is reached when the inductor current falls to 0 exactly at the end of the commutation cycle. Now we will look at the graph. If we look at this graph, we have voltage versus current characteristics. We can see that discontinuous and continuous characteristics are behaving like this. Now my friend Shoham Mitra will say about this.
Thank you, Toritra. Thank you very much. Now we gonna talk about the factors on which the efficiency of the buck conductor depends. So there are two types of losses on which the efficiency of the buck conductor depends. One is conduction loss, one is switching loss. First, we will talk about the conduction loss. Change the slide, please. So in conduction loss depends on several factors. The first factors is on the load resistance when the transistor or the MOSFET switch is conducting. Second factor is the diode forward voltage drop, which is usually sometimes 0.7 volt or 0.4 volt if we use a Schottky diode. Third factor is inductor winding resistance, and the fourth factor is capacitor equivalent series resistance. Now we are going to talk about the switching loss. Change the slide, please. Switching loss. The switching loss also depends on several many factors. The first factor is volt ampere overlap loss. The second factor is frequency loss. The third factor is reverse latence loss, and the fourth factor is losses due to driving MOSFET gate and controller consumption. And the last factor is transistor leakage current loss and controller standby consumption. Next slide, please. Now we are going to talk about the impedance matching. Buck converter uses this impedance matching technology to maximize the power transfer. We can find the application of impedance matching in maximum power point tracker, which is used in photovoltaic system. So the next slide. So the coding slide will be described by my friend Aman Shah.
Okay, thank you to all the previous speakers who have explained the theory part. Now I would like to take on the coding area. So sir, this is the coding. So first of all, we have taken the input voltage of buck converter Vs. Then we have taken the input voltage, output voltage of the buck converter V0. We have fixed the switching frequency of the converter at 20,000 Hertz. And the value of I0 max is 15.5 amperes, which is a maximum value of load current. And we know that the diode voltage of silicon is 0.7 volt. After that, we have used the formula of duty ratio, which is output voltage by input voltage. After that, we have taken the magnitude of input current IS, and we have calculated the operating time of converter in seconds by using the formula T equal to 1 by 20,000 Hertz. After that, we have found the value of ripple current, and simultaneously we have found the value of ripple voltage. And after that, we have calculated the value of inductance L and capacitance C in Henry and Farad respectively. So next slide, Subham. After that, we have found the current through the switch in amperes and voltage through the switch in volts, which is ISW and VSW respectively. And after that, we have found the current through the diode in amperes. And finally, we have found the power dissipation of diode, PD. And lastly, we have calculated the output power P0 and the input power Pi. And the last thing which we have done is calculate the efficiency, which by the formula output power by input power into 100. Now, and after that, we have printed the output. So now we will show the output. Shobham, please show it.
Yes, sir. I show the Matlab software, the coding. I copy paste for coding in this
Matlab, and then I want to run it.
So sir, here we are entering the input voltage, 24 volts. The output voltage we have entered is.
One thing, I already inform you.
Sir,
Don't
we will show
so
the graphical. We
yeah,
will show
just
the
go with the
graphical one.
graphical way.
Okay, we will directly showing the graphical coding. Subham, please open the PPT.
Okay.
Okay. Now my friend Subham will explain the graphical one, please.
Oh,
Uh, do you not able to run graphical one through Matlab?
Yes, sir.
yes,
Yes, sir. We
sir.
are.
We
Subham,
pass through the preliminary coding, and then I explain the
Okay, so
graphical.
you follow your steps. So if you go with the step by step, you may go with no issue, right?
Okay, sir. Please give me some time. I can show what. Yes, sir. Aman, please share. Please say.
PSU, please enter the output voltage 12. Enter the input current 0.4 amperes. And sir, here we are getting the output of the normal coding. Now we will show the output of our graphical coding. Subham, please show it
Yes, sir.
and explain the code.
This is the graphical coding, and also in PPT it's can be shown. And this is the coding we show in the PPT portion, and I will show you in Matlab also. And this is the whole coding section, and then wait a second. This is the page which we create after it's run. It's looking like that, and is the final thing. And now I show it in Matlab. So this is the code, and if we run this, it's showing like that. And if we enter the values, some value like 21. The input voltage is like 11, and the maximum current can be 0.9, or input current can be 0.4. If we show the duty ratio, it's like that, and the input power is this, and output power is then the efficiency is approximately 117, which have to be around 100. So if we change the input current and maximum current, it will vary upon the output power and input power. If we plot the graph, that's like this. And if we show the coding and merge it with this run panel, if we show you, then it's the coding, fast coding, which is control the duty ratio button, and the duty ratio and the edit one is the input voltage, and the edit two is the output voltage, and that's like that we do that. And we control the duty ratio button, and after that the output power button will be controlled by this coding, and this is the uh, uh, edit 2 and edit 3. These two are working for the output power. And after this button, efficiency button, will be run by this coding, and this is coding where the edit 2, edit 3, edit 1, and edit 6. That's all the buttons are working for the efficiency button. And after that we can show you that uh, one second, sir. This is the coding for the graph portion. X level, Y level, and the title will be also shown in the plot. And this is the coding for the input power button, and the edit 1 and edit 6. These two buttons are used to handle the output power. So that's all from my side. Please, Aman, conclude the session, our presentation.
Okay, good. Okay, is it complete?
No,
Sir,
sir.
okay, sir. Okay, sir. Now we would like to conclude our session. So we have seen that from our coding, that using the Matlab software, we designed and implemented a DC to DC buck converter. And with that coding, we have found the duty ratio, input power, output power, and efficiency successfully. So that's all. Thanks. Thank you for giving us the opportunity to make this project.
Thank you,
Okay,
sir.
that's a very good
Thank you.
presentations, and this is a group presentation. So I have a question. So what actually a buck converter? Can you tell me some application of a buck converter?
Sir, application part of some PPT, one slide is for that application part.
Okay,
Also
so
by Sumo or Somo Chakraborty explain the application.
yeah, so what actually application means is it a high to low voltage conversion?
Yes, sir. Yes, sir. This
Yes,
is a
sir.
So
machine through which
Step
the
down.
step
step
down
down.
voltage.
So why? So instead of using that, we may use a step down transformer.
Step down transformer. In step down transformer, there are some leakage.
Well,
Uh,
step down transformers are generally very big type
AC
machines. So these
transformer
buck converters are very small, and these are basically used in means complex, not complex, but in CPUs where we can with a little area I can use that part.
Low
transformer
voltage
is
circuit.
bulky.
And sir, the output they like the external components are very less as compared to transformer. That's why we use.
Oh, transformer we also have. We can also arrange a small transformer also be possible. But what actually range means? Is it a DC to DC conversion, right? This bar.
Yes, sir.
sir, yes, sir.
But in case of transformer,
It is
what
AC
we
to AC, sir.
use AC
AC,
to
sir.
Sir,
AC. So
AC
to
to AC.
so that actually a main difference, right? And the next thing is that so you use a buck converter, okay, DC to DC. So what actually range means? Uh,
Yes, sir.
what
With
actually DC values?
yes, sir. The input range is 0 to 24 volt, and the output voltage range is 0 to 12 volt. For that, we when we do the simulation, the inputs are within that range. When I give the yes,
Okay,
if
0 to 24.
proper input and output voltage, so the efficiency of the circuit will be hampered, and that circuit is not working.
Okay, another question is that if we go with a buck converter, is there any chance of getting the noise or anti-aliasing effects or anything is possible to occur?
Yes, sir. Also, it is not in ideal case, but when we use in hand or in practical cases, it can be some error or some noise can be done in
Means,
DC.
so if it's this actually overlapping, so if we means it's I don't know because some of the cases when we convert AC to DC or AC to AC or whatever DC to DC when we convert, it's some of the cases what we face that actually a overlapping of a signal.
Yes, sir. Yes,
Right,
sir.
some of the cases we face, right?
Yes, yes, sir.
So in that case what we need to use
Also,
to filter out it, what we need
filter out it.
just for no issue, I just ask you. So DC to DC, it's a very not a very big issue in case of DC to DC. DC to DC, I think not. It's happen very. It's not make a very big issue. Okay, fine. So very good presentation because it's a group presentation and how we present that is very good and very time effectively. So that's very good. Thank you. So next we go. So any questions you have from me? So what do you think? Do you get some idea from this session?
Yes,
Yes,
sir.
sir. Yes, sir.
If
Obviously,
we,
Yes,
if
sir,
we
yes, sir.
we get
okay.
a experience to have to handle a great project. We do all together a project sanction
The
and
thing is that here we want to say one thing. The projects, whatever we go with, it's not a actually it's a mini project may consider. So this actually generally what actually thinks project is maximum a project should be some practical implementation should be there. Here I actually try to say that a project, it may be a whatever we do, how we implement it. Not in case of, if you go with a Matlab based project, that maybe a big projects are there, analysis, this kind of projects are there. So there's a good and big project, but there's a no use case. So a number of things we copy and paste. So I don't prefer to go with that. So obviously, I recommend all of you, please, after the sessions, just go with the things, try to complete a big project using MATLAB code. So it maybe take a 1 month or 2 months, but shortly some ideas and try to implement it, because this is actually very small. We don't have a scope to implement big things. So I request all the students from all the groups, after that sessions, please try to make some big projects using MATLAB. Right, thank you. So group number 2.
Thank you, sir.
Yeah, group number 2. Group number
স্যার
2.
গ্রুপ নাম্বার 2 এর স্যার একজন প্রেজেন্ট নেই, তো ও আসলে প্রেজেন্টেশনটা দেব, মানে যে
কে প্রেজেন্ট
প্রেজেন্টেশন
নেই?
করবে হীরাব্রত কোলে।
কেন
আরো
আসনি
দুজন
কেন এখনো?
তো আরো দুজন, আমরা টোটাল 3জন প্রেজেন্টেশন করেছি, আর দুজন নেই, তাদের কোনো খবর নেই। তো
তো
ওই
তাড়াতাড়ি তাকে জয়েন করতে হবে, কারণ পরপর না নিলে তো হ্যাপাজার্ড হয়ে যাবে ব্যাপারটা। জয়েন করেনি কেন?
স্যার একটু প্রবলেম হয়ে গেছে, তার ওই জন্য একটু জয়েন করেনি। করবে, একটু পরেই
কতক্ষণ
করবে,
লাগবে?
15-20 মিনিটের মধ্যেই করবে হয়তো।
গ্রুপ নাম্বার 3। Group number 3. Group number 3.
Yes, sir.
Yeah, so who actually want to present?
Hello.
Yeah, who want to present from group number 3?
I'm going to present the PPT and Shubhama is going to start.
Subarna Pal. Okay, I make you presenter.
Okay, sir. So is it visible?
Yeah, it's visible.
How to minimize this thing?
Go to meeting window.
Yes, sir.
Just drag and drop it. Or you may cross sign is there. So you may go with that also.
No.
Not red one. Not red one. It's a leave your meeting. Other.
Okay, let me just drag and keep it aside.
Do one thing. Go with the F5. That's automatically hide. F5. It goes to.
It's not doing anything.
Select your PPT and click on F5.
Okay.
Yeah.
Yes, Shubhama, please start. Hello.
Hello, sir.
Yeah.
Good afternoon, sir. I'm all are from Group 3, and my team member is Swagatam Kumar Pan, Nilashish Kundu, and Suborna Pal, Tomrodip Sinha, and myself is Subhamoy Mondal. Sir, we are present a GUI calculator. And next slide, please. Next. Sir, that's the introduction of Matlab. Matlab is a sir, high-level programming language and an interactive development software for technical computing. Sir, it allows the user to solve very fast tasks which require huge amount of computers. This is possible due to its embedded function and capabilities. Sir, Matlab offers extended graphical function having easy to use tools for data display in various formats. Sir, in order to extend a working environment beyond its standard capabilities, there are a number of tools which can be installed or
Shubhamoy,
yes,
Shubhamoy,
sir.
I just want to inform you one thing. When you presenting, yes, so try to not saying sir, right? So that's not a good thing, right? So try to hide these things. So it's maybe you don't understand. So don't after every line don't add sir, right?
Okay, okay, sir.
Is it clear? Okay.
Sir, may I continue?
Yeah, exactly. Continue.
In order to extend this working environment beyond its standard capabilities, there are a number of tools which can be inserted offering additional features for solving electrical engineering problems with the computer. It can be successfully applied in various fields such as image processing, statistics, optimization, signal processing, etc. It's almost all electrical engineers use Matlab at some point. Many instructors believe this application must be studied during first year of the college, especially during introductory electrical engineering lectures. The use of Matlab in education not only improves and accelerates learning but also helps the student to be prepared for a productive career. Using MATLAB-based curricula, the professor can build a base of an education which should help the student throughout the university. From specific lectures and laboratories till complex application in industry, MATLAB offers a flexible environment for multifunctional teams and for a multidisciplinary research. So next continue my friend Suborna Pal.
Yes, sir. Okay, thank you, Shubhamay, for passing me this following presentation. So I would like to continue it further. As you can see that MATLAB is a particular software that we had like it was developed for the project purpose. But as you can see that it have conquered many fields like artificial intelligence, robotics, image processing, wireless communication, machine learning, data analytics, and whatnot. But basically, like if you can see, then if you compare any other language like C programming or C++, you can see that MATLAB is quite easy to handle and it's kind of portable. It enables the computation, programming, and graphic visualizing the results that have we haven't done it like in any of the softwares more precisely. Okay, let's go to the next slide. So these are just some of the materials that we can use in MATLAB. So there we have statistic and machine learning, curve fitting, control systems, signal processing, mapping, deep learning, financial analysis, image processing, text analysis, electric vehicle designing, aerospace, audio toolbox, and whatnot. So now I would like to hand over the presentation to my friend Swagatam so that he can simulate it. Let me just stop the screen sharing. Swagatam, please continue.
Sir, give me the permission to share the screen.
Yeah, I already provide you. Check it. Swagatam, I already provide you permission.
Yes, sir. Sir, 1 minute, sir. Sir, my MATLAB is not opening just.
Okay, okay, okay.
Sir, is my screen visible, sir? Sir, is my screen visible?
Yeah, it's visible. It's visible.
Sir, this is the program which was done using the GUI, and this was about the calculator. Sir, here I press the run button. Yes, sir. Sir, and here are all the buttons which are working, sir. And even the cancel button is also working, and all the operations are even working.
Okay.
Sir,
So
here
please,
are the
can
point
you
buttons
go
and
with your
up and
coding
square
part?
button also. Yes, sir. Obviously, sir. Sir, here is the coding part. Sir, firstly, I designed using the GUI platform, where I selected the buttons and the text and the edit box, and then with the properties, means after that I changed the string and static box also, and then the after that I saved it, and then the commands are used, like for the number 4 the get handles command is used, and as it is a string, so 4, then in a similar way the numbers are there, and then for the pi there is a mathematical calculation of 3.14, and for the square also to the power 2, and even for the root also the number 2 string is used. And here for the equals function there are 4 cases which are arrived for a b c d, and here are the 4 cases of number 2 string using the get handles command. Yes, and here is for divide, multiplication, subtraction, and addition, sir, and here is for the reset cancel button. Yes, sir. Now I would pass to Subarna, sir.
Okay. One question is there. How you concat these numbers? So I think there is some command is there to concat, because this
Sir, pardon
string,
me, sir.
whatever, do you use any concatenation operator within your code?
No, sir.
So how you display 2 plus 3, this kind of things?
Yes, the concatenation. Yes, it is used, I think so.
So the thing is that please go through your code and check it, right? So what are the things you submitted? Is it everything is clear to you or not? Okay, otherwise it's okay. But number, okay, just means whatever the things are there, please go through it properly, right? And so if it's possible, some modification required, please go with that, right? Otherwise it's fine, no issue. So calculator is working fine. And the thing is that okay, so next part, who actually continue? Just continue.
Sir, Subarna will continue with that. Subarna, please present the PPT.
Yes, sir. Please give me the presenter part.
Suborna Pal, right? Yeah.
Yes, sir. So, thank you, Swagatam, for passing me the PPT again. So here I would like to conclude that using MATLAB is not just like consume like
Suborna, it's not audible. Suborna, it's not audible. Yeah, Suborna,
by
is
which
it?
we can
Yeah.
shall I continue?
Yeah, continue, Suborna. So it's actually last few minutes we can't get you. So please continue.
Oh, sorry. Actually, because maybe because of my network or something like that. Okay. So, MATLAB, as you can see that with MATLAB, we can do our projects very quickly and portably, and MATLAB is kind of very useful for data analysis. Its interactive and graphical nature allows us to analyze and give immediate results, very appropriate to improve learning by a better understanding of electrical engineering fundamental concepts. So, this was our last conclusions, and from here I would like to stop my presentation, and thanks again for giving us this golden opportunity to present the projects in front of all of you.
Okay, and that's a good presentations by this group number 3. But one thing I want to mention, so PPT must not be this kind. Okay, so it may be this fine, whatever you make, but from next time, try to make a PPT in bullets, number of points, right? PPT must not be elaborative one, right? Just check it. Means the thing is that all things are very important for your studies. So your presentation skill is very good. Means Shuvana, what you present, the presentation skill is great, but the whatever the present, the PPT slide you need to check, right?
Okay,
So
sir.
group 1, what they made, these are perfect things. There's a bullet point out all the points. This is a great one. So always when you're going to make any PPT, you need to focus on that, right? Okay, so group number 4.
Yes, sir.
Yeah, who want to present?
Sir, Anubhav Mukherjee, whose mic is not off. You can give that one the presentation.
Yeah.
Yes, sir. So, is it visible?
Yeah, it's visible.
So, is it full screen?
No.
Yes. So, good afternoon. My name is Anubhav Mukherjee from Narla Institute of Technology, and we are Group 4 here to present our project, which is designing of analog clock using Matlab. So, an analog clock is a clock where an analog clock has moving hands, where the smaller one is the hours hand and travels 30 degree in 1 hour, and the longer one is the minutes hand and travel 360 degree in an hour. The second hands rotate with a step of 6 degree. An analog clock tells time where the hands sweep around the dial, and the position of the hands determine the measurement of the time. So in MATLAB, our objective is to make this analog clock. The time in the shown in the system, that is in our PCs, can be found with the MATLAB command clock, which will directly show the time set on our systems. So our project is basically divided into 4 main steps. That is plot functioning, basic of date and time, and drawing of the static clock, and the last one is giving life to the clock and draw more clocks. So the first step is the basic plot of the program. This is the point in a plane can be determined by x comma y coordinates. So in order to make a circle, the coordinate should be x coordinate should be r, that is the radius, into cos theta, where theta is the angle that runs from 0 to 360 degree. And here in this code we used here delete plot is also used, which will indicate the movement of the hands in the clock. The next steps will be said by our other group members. Others, please continue.
Thank you, Anubhav, for giving this following presentation. The step 2, basic of date and time. Let's check ways using date and time function. Date time function has many uses. We will know them in next few minutes. Date time now give the present time. So how to get the current date? Time is using clock function, but the difference is the date time function creates variable of class date time, but clock will turn contains date and time. We observe these decimal points in 4 decimal points. So now my friend Suraj will continue the next part. Thank you.
Thank you, others, for giving me the opportunity. In the first and second step, we learned about the analog clock and basic of the clock. But in this step, we are going to learn how to design an analog clock. Next slide, please. From this code, we can design an analog clock. For that, we have to first draw a circle, and we have to place a number 1 to 12 in their respective position. That's how we can draw an analog clock. From that, next, my friend Rakesh will Sonu.
Thank you, Suraj, for passing. Good afternoon, sir. Now I will continue. Step 4 is giving life to the clock. That is, it is the step how the hour, minute, and second hand will move within the loop. Next slide. Now we have to give movements to the hands of the clock. That means we have to change them based on time. So we have to create a infinite movements by drawing code in it. Here the first code is for second hand, second code is for minute hand, and third code is for hour hand. In the code 0 is to 360 means all the hands of the clock will move 0 degree to 360 degree, that is in a whole circle. Second hand moves 6 degree per second, minute hand moves 6 degree per minute, and the hour hand moves with 30 degree per hour. We will update the clock for every 1 second. Now my friend Rakesh will continue from the next step.
Thank you, Sonu. Now we will discuss about step 5. The step 5 is creating multiple clocks. These are steps said previously, which can be used to make more analog clock. Now this code is for our project analog clock. The conclusion of this topic: it is an analog clock. It may be placed on any axis, move and resize as long as valid access handle is provided. It may also be initialized to run as a real-time clock or updated with an offline time from any source. That is it from our project. Hope you like. Thank you.
Okay.
And sir, this is
Yeah.
our output. So this is the code that we used, and if we run it, it will show the output. Yes, this is the present time, and here you can see the system time. Yes, sir, that is it.
Okay, fine. So that's good projects, and you also completed the things. But the thing is that you have another 4 minutes in your hand. Okay, no issue. So it's okay, no issue with your projects and presentations. So next, go with the next one. Group number 2. Can you present? Group number 2. Group number 2.
Yes, sir.
Yeah. So who want to present? Group number 6 also be there. Group number 2. Group number 2 first present, then group number 6 or group number 6 present. Want to present now? Group number 6.
Group number 6.
Like laptop is join.
Okay. So group number 2. So present. Group number 2. Who want to present first? From group number 2, who want to present? From group number 2, who want to present?
হ্যালো স্যার, স্যার, হ্যাঁ স্যার, আমি প্রেজেন্ট করছি স্যার।
Shayok.
This is visible.
Yeah, it's visible.
So, good afternoon, everyone. My name is Somo Palui. Now I am pursuing BTech in Electrical Engineering from Narula Institute of Technology. Today we are going to present a project on an inverter using Matlab. Let's start the presentation. Next slide. So this is our group members, and this is the contents. Next. Project objective. To design this project, an inverter to design first of all, to design a inverter made by using MATLAB Simulink, and second, making analyze on the output voltage, and third, to study the function on PWM in three-phase inverter, and fourth, to make the output waveform in MATLAB Simulink. And next part will be continued by my fellow mates, Shaikh Sarkar.
Thank you, Shomapali.
Thank you, Shomapali.
I am Shayok Sarkar. Now I'm discuss about the inverter. An inverter can be defined as it is an compact and rectangular shaped electrical equipment used to convert DC to AC. The application of the DC involves several small types of equipment like solar power system. Direct DC is used is many of small electrical equipment such as polar power system, power batteries, power sources, fuel cells, because these are simply produced direct DC. The basic role of an inverter is to change DC power into AC power. The AC power can be supplied to homes and industries using the public utility, otherwise power grid. The alternating power system of the batteries can store only DC power. In some cases, generally the input voltage is lesser whenever the output voltage is equivalent to the grid power voltage of either 120 volt, otherwise 240 volt, based on the country. These devices are
standalone devices from some applications like solar power. And inverter can be classified into two major types, single phase and three phase. Single phase inverter is the type of inverter in which only one DC source is used, and the output thus formed is a single phase AC waveform. Alternatively, a three-phase inverter use two input DC sources using 6 IGBT transistor to convert DC voltage into AC voltage, and output of such a circuit will be a three-phase AC waveform with a phase difference of 120. Thank you. And next part will be discuss our fellow mates. Hirabukole.
Hello everyone, my name is Hirabro Kole. So this is a circuit of a simple three-phase inverter made in Simulink. What it does is it converts the DC voltage to the AC voltage supply. Here the MOSFETs are being used as a switch, and the gate voltage of those 6 MOSFETs are being provided by 6 pulse width modulator. Each phase consists of 2 MOSFETs, and hence 6 MOSFETs for 3 phases. A synchronous motor is connected as a load. The frequency of the frequency of the output signal can be controlled by changing the firing angle of those 6 MOSFETs. So Shayuk, can you change slide? So here we can see the output of the circuit. So the upper one is the output, and the second one is the input of the circuit. So as we can see that there are three color signal. Those represent 3 phases, and the lower portion is the single DC voltage. So this is the actual output of the circuit. So finally, I want to conclude by telling that this inverter can be used in several ways. It can be used for controlling defined level of voltages and other class of power converter and inverters. The level of multi-level configuration can be increased, and further improvements in terms of performance and quality issues can be broadly studied and could be implemented with these hardware circuits. Thank you.
Okay, fine. So you go with this converter. So some applications, can you specify where you want to use?
Electric vehicle.
Electric vehicle. What is the voltage rating of electric vehicle? Electric vehicle voltage rating. What is the voltage rating they actually followed? So what are the parts of, means if you consider electric vehicles, so there is a operation voltage. Can you tell me? Any idea?
Actually,
Yes.
they do not use a single battery. They use a number of cells as a battery pack. So it can be used in different various voltages.
No,
Like
obviously there is some fixed voltage.
Yes, they can be used in between a range of 200 to 700, 600, like that.
What, 200 to 700 watt? Voltage?
Volts. Yes.
700 volt. Electric.
Yes.
This is AC or DC?
So this is the I'm telling about the input voltage.
Okay, input voltage. So is it a AC or DC? Input voltage,
voltage.
AC. Yeah.
DC voltage that is coming from the battery pack.
700 volt DC. Can you imagine? Why do obviously can anyone? So this is actually not a very difficult thing. Means just exchange. So just we discuss these things. That is why we switch to AC. So hopefully you all know. Previously we used DC voltage for home supply, means domestic supply. but now we are using AC. Why? Any idea? Anyone have any idea? Hopefully all know that previously in the first we use a DC voltage. Yeah.
Actually the appliances still run on the DC voltage only. The supply that is coming is in the AC.
Appliances still run in DC voltage. So the thing is that means which appliances run in means, do you provide any appliance input as a DC voltage?
No. There is a rectifier inside the thing which converts the AC to DC voltage.
Okay, why we actually go with a DC voltage in appliances?
So because in DC the losses are very less.
The thing is that why we all the means why we domestic voltage? So what are the domestic now voltage rating? Is it a AC or DC?
AC 230 volt.
230 volt?
RMS.
AC or DC?
AC RMS value of AC voltage.
Okay. So 230 volt AC. So the thing is that as it is a 230 volt AC, and when we go with the things, it's a when sorry for this interruption. So this very big noise is there outside due to this election, right? So just wait 1 or 2 seconds. But in our home, whatever the supply we use, microwave, refrigerator, it's actually controller. This compressor actually. So if we consider the AC or refrigerator, it's have a two. You mentioned this two kind of voltage. So this is the compressor actually use a AC, but controller, whatever the controller is there within this board, motherboard actually work with a DC, right?
Yes.
So the thing is that motherboard work with, because the electronic circuit is there, and there is one microcontroller. So microcontroller, whatever microcontroller nowadays we are using, this actually work with a 5 volt DC. Right, not 700 volt DC. 700 volt is an enormous DC supply, and this very hazardous one. Hopefully, you all know, because I am not from. I actually from electronics engineering background, so I only dealt with up to 5 to 12 volt. You are the people who use this more than this. So electrical engineers actually work with a higher voltage. Electronics engineer actually work with a lower voltage, right? So 700 volt is it possible? What do you think? 700 volt means do you check somewhere you use? Yes, where you check get the 700 volt? I think I need to clarify also if I am wrong. So where you get the 700? Anywhere? So you check anything 700 written?
Sir, actually
Yes.
I was guessing.
Okay. Then fine. That's fine. No issue. The thing is that DC actually past days we use DC, right? Direct. So what are the current supplies? Domestic supply also be DC when it's first started. But there is severe issues with DC. So if someone means if this enormous DC is supplied and anyone gets shocked, that means if DC voltage 230 volt DC, if they shocked by means some voltage is passing through your body, then you don't have to do anything. You are just finished, right? So due to its AC, so why there's some possibilities are there, right? So and there's a long distance communication purpose, we also prefer to go with the AC. Obviously DC also have some facility advantages, disadvantages, but obviously AC is more advantageous, so we all moving to this. But now that actually a main concept what actually you mention, the thing is that nowadays whatever the supply actually we again moving towards DC, because this is the biggest challenge. So 230 volt AC is there, our current supply, but our all the devices, electronic devices, working with just 12 volt or 24 volt maximum DC. So is it not a voltage wastage? What do you think? Is it a wastage of voltage? Anyone can reflect.
Yes, sir.
Sir,
So
actually,
how?
in the power grid, there are this control panel which works in DC voltage, right?
Yeah,
So
yeah.
in this DC voltage is of 220 volt. Actually, these voltage is taken from a battery pack consists of several battery cells.
No, so that actually the difference. Controller take 220 volt DC. No, that is
Controller
a
doesn't take
different.
220 volt DC. It never
Okay.
can take 220 volt DC. It only works in
Exactly.
12 volt or something, 18 volt like that.
5 volt. 5 volt. PLC
Yes.
actually go with a previously PLC work with a 24 volt. Nowadays that also work with a 12 volt actually. And controllers generally, whatever the general controller, 5 volt is enough, and now 3.3 volt controllers also be available in the market. So these are the things. Okay, so you actually consider this power grid is this is clear. Smart controller is there, so smart relays are there in systems in power stations. So that actually conversion purpose we use there. Actually, I think you actually asking me regarding smart relays, right? This microcontroller relays. That controller, do you want to mention?
Sir.
Do you heard the term relays, all of you?
Yes,
So
sir.
this is a very common term for electrical engineers. So fast automation device also be a relay considered as a right. Okay, that's fine. So there's a discussion regarding this topics and nothing else. We actually going to. So that's fine.
So that's
Otherwise,
fine. Otherwise, you
okay, it's echoed.
it's equal.
Okay, okay.
Hello, sir.
Yeah.
Yeah.
Sir, before group 6, we are from group 5. So can we present?
Yeah, yeah. Obviously,
Yeah,
obviously present.
obviously
Oh,
present.
sir. So please, sir, make presenter to Sampath.
Shampoo. Yeah.
স্যার এইটা না আরেকটা যেটা আছে কথা বলে না এটা।
Yeah.
Akash, please start.
Hello.
Hello.
Hello. Good afternoon, sir. My name is Akash Vishwas. Today we discuss about our topic solar power generation for home application using Matlab Simulink. This is our group members name. We are 6 members. Me, Akash Vishwas, Arif Hussain, Boris Dasta, Minmay Ghosh, Sampath Pal, and Sayantan. Next slide. So here is our content. We have 8 content: objective, introduction, component required, application, simulation diagram, result, conclusion, and reference. Next slide, please. Now I discuss about objective part. On completion of this project, the reader will have knowledge on basic components of solar PV system and its merits and demerits. Here we use MATLAB to determine the simulation of a PV array supplying single-phase AC distribution system. Also, MATLAB simulating model of different control strategies of power condensing unit. The importance of MATLAB Simulink model in improving the efficiency of the overall solar PV system. We design the characteristics of solar PV panel and its MATLAB Simulink model of solar PV power conditioning unit. So that's up to my turn. Next part will discuss my fellow mate Arif Hussain.
So my part is introduction, so I am discuss for introduction part. The renewable energy resource, the energy due to the photovoltaic efficient can be considered the most essential and prerequisite sustainable and resource. Because of the ubiquity, abundance and sustainability of solar radiant energy. Regardless of the intermittency of sunlight, solar energy is only available in scale. Recently, photovoltaic system is recognized to be the forefront and renewable electric power generation. It can generate direct current electricity without environmental impact and contamination when exposed to solar radiation. In a semiconductor device, the PV system is static, fluid, free of moving part, and has the little operation and maintenance cost. Application of photovoltaic as the electrical energy source so increasing trend both in implementation on spread area over the world and capacity of plant. This trend is triggered by many factors such as the increasing of fossil fuels cost and declination of production cost per kilowatt. Electric for photovoltaic and also technology development thus cause photovoltaic power conversion more efficient. So my part is end and next part discuss my friend Gorik Datta.
My name is Inverter.
Please mute someone. Someone actually background noise is there coming. So I think please check someone. Someone background noise is coming. Okay, now I think fine. Yes, continue, Gorik.
My name is Gauri Datta. My college name is Narula Institute of Technology. Today my project part is component required. We have used components to make the project. Component required are constant module, PV array, voltage measurement, scope, capacitor, inductor, IGBT or diode, pulse generator, universal bridge, PWM generator. Our next part will be discussed by my friend Mrinmay Ghosh.
Thank you, Goirik Datto. My part is application of the solar PV cell. Various kind of application of solar PV cell. These are solar farms. Many acres of PV panels can provide utility scale power from tens megawatt to more than gigawatt of electricity. These are large systems using fixed or sun tracking panels feed power into municipal or regional grids. Second one, remote locations. It is not always cost effective, convenient, or even possible to extend power lines to locations where electricity is needed. PV can be the solution for rural homes, villages, and developing nations and lighthouses, etc. And next one, stand-alone power. In urban areas, PV can power stand-alone devices, tools, and meters. Here, PV can meet the need for electricity for parking meters, lighting for roadways, etc. And another is building-related needs. In building-related, PV panels mounted on roofs or ground can supply electricity. PV material can also be integrated building structure as windows, roofs, tiles, etc. And another one, military uses. And soldiers can carry lightweight PV for charging electronic equipment in field or remote bases. And next, transportation. PV can provide auxiliary power for vehicles such as cars and boats, etc. This is up to my part, and the next part will be continued our group members Sampath Pal.
Good afternoon, sir. My name is Sampath Pal. I am going to explain the simulation diagram and the result of this project. This project is done on Matlab R 2015A software. First, we use a PV array which have 20 parallel strings and 5 series connected modules per string. In this PV array, we give input to the IR and T terminal, which are irradiation and temperature value. We used constant blocks for these inputs. We set the IR value to 1500 and T value to 25. Then we took DC output from the PV array. We connected a capacitor parallel to the output, and using a voltmeter and scope, we plotted the output voltage versus time graph. That is this. Here you can see the voltage is just above the 180 voltage. We used the capacitor here to reduce the ripple of the output. Then we used the boost converter circuit to increase the value of DC output voltage. In this boost converter circuit, we used an inductor and a diode serially and a IGBT and a capacitor parallelly. We used a pulse generator to give the input to the G terminal, that is gate terminal of the IGBT. A boost converter or a step-up converter is a DC to DC power converter which steps up the voltage while stepping down the current. So when we give the pulse to the gate terminal of the IGBT, the inductor will be charged and the current will flow through the inductor and from the collector to the emitter terminal of the IGBT. In this time, the current through the diode D1 will be 0. Now, when we do not give the pulse to the gate terminal, the current will not flow through the IGBT. This time, the current will flow through the diode D1. This time, the value of the current will also be changed. The current will be lesser than the previous time. But as we know, the tendency of an inductor is to resist the sudden changes in current. So now it will act as a source, and the total voltage of the output side will be the sum of the input side voltage plus the inductor voltage. So that is DC voltage will be increased in this way. Now we used the voltage measurement and scope blocks to see the voltage versus time graph. In this graph, we can see the voltage is increased. Finally, we have to convert this DC voltage to AC voltage. In this case, we used an universal bridge and a PWM generator. We used a single phase full bridge 4 pulses type generator and unsynchronized mode of operation. We used 60 Hz frequency and initial phase of 90 degrees. For universal bridge, we use the number of bridge arms equal to 2 because we are only considering single phase values, and we used IGBT as a power electronic device. I explained the working principle of IGBT before. There are 4 IGBTs are connected in this bridge. We are giving the pulse to the 2 IGBTs at a time. So first, when we are giving the first pulse, it will create positive AC voltage, and then when we give the second pulse to the bridge, it will provide negative AC voltage. And in this way, it will generate a proper AC voltage. This is the simplest explaining of this universal bridge. I can explain the full working principle of this bridge by drawing it, but I have limited time, so I am not able to do it. Lastly, we use an LC filter to create a proper sinusoidal AC waveform that is shown in this scope. Now, the next part will be discussed by our next and the final member. Thank you.
Thank you. Thank you, Sampath, to giving me the chance. Good afternoon, sir, and good afternoon, everyone. My name is Shayantande, and I'm also from electrical department. So now we came to the conclusion that this project, that solar power generation, is although an hardware and also software project. Here we have done by software and estimated the power generation with PV array for home application using Matlab Simulink. And we have run the project, and you can see the finally we got the DC to AC voltage from PV array using following Matlab tools, which is already explained by my fellow members. So mainly the future of PV continues to be one of intense research and development, where thin films will overtake crystalline silicon in cost and efficiency. It is foreseen that the role of PV in the generation of electricity will overtake than other form of renewable energy, and that 50% of all new buildings will incorporate PV in their design. While the debates over the use of nuclear fuel continues despite doubts as to its long term of economic and environment viability. So the main keyword of this project is solar power is the best renewable resources of all other energy resources. So next, reference. We have done this project on Matlab, R2015A, and we have taken help from our respective college teachers and also from online resources, and obviously with help and full support with our fellow team members. Next, please. So thank you all of you. That's all our project. Have a great day.
Okay, so that's fine. Very good presentations. And the thing is that a good topic you choose. So when solar power we consider, so do you work with the solar power? Means do you interested in this field of solar energy, and you go with some of the tasks you already implemented other than this one? Anything you implemented other than this, or this actually your first one?
No, this actually the first one.
It's actually first, but in diploma we're using only PV array. So just we can see that.
Smart grid system. Not like this. This is the second actually.
Okay.
But we this is the first solar project.
No. You make so you do you implement anything using a solar base? So this clear.
No, sir, not implement.
Okay. So when you go with the solar based implementation, so one of the biggest challenge is their voltage management. Means whatever the temperature, outside temperature, means whatever the, it's actually not all the times it's provided all the same kind of voltage is not coming. So how you manage? So these things is described. Do you understand my question? So this solar, whatever energy it's generate, or whatever the voltage is generated through this PV cell, that's not a uniform, right? Is it uniform?
No, not a uniform, and it is in.
Actually, you are using two devices, so please mute one device and continue with the second one.
Yeah. Hello.
Yeah. Continue.
হ্যাঁ স্যার বলুন আপনি কি বলছিলেন?
হ্যাঁ মানে দুটো থেকে কি মানে কিভাবে করো এটাকে ম্যানেজ কিভাবে করবে, মানে ইউনিফর্ম তো নয়, তার জন্য কি সলিউশন আছে?
আমার তো দরকার এসি ওয়েভফর্ম, ঠিক আছে? আমি তো ফার্স্টে যে স্কোপ 1 যেটা নিয়েছি সেখানে আমি দেখিয়েছি অ্যাকচুয়ালি কি বেরোচ্ছে র মেটেরিয়াল যেটা, সেটা আমি স্কোপ 1 এ ফেলে দিই। এবার আমি সেটাকে ডিসি ভোল্টেজটাকে বাড়িয়ে তারপর সেটাকে এসি করেছি। এবং এসি করার জন্য এই দুটো যদি এলসি ফিল্টারটা আমি ইউজ না করতাম তাহলে একদম মানে র এসিটা বেরোতো আমার, নট ফিল্টার্ড এসি যেটা সেটা বেরোতো। এবার সেটাকে আমরা ফিল্টার করে যে ওয়েভফর্মটা অ্যাকচুয়ালি আসছে, মানে লাস্ট যেটা দেখিয়েছি এই যে এই ওয়েভফর্মটা আসছে আমাদের, তো এটা ফিল্টার করার জন্য, না করলে কিন্তু এই এত সুন্দর ওয়েভফর্ম আসতো না।
তো তোমাদের এখানে কোনো ব্যাটারি স্টোরেজ ব্যাটারি কিছু ইউজ করেছো এখানে?
না, এখানে হচ্ছে এই যে লাস্ট হচ্ছে লোড রেজিস্ট্যান্স, এই এখানে আমি একটা লোড রেজিস্ট্যান্স ইউজ করেছি জাস্ট। এখানে এবার যত খুশি আমি লোড রেজিস্ট্যান্স ইউজ করা যেতে পারে, অসুবিধা নেই। এটা অ্যাকচুয়ালি হোম অ্যাপ্লিকেশনের জন্য, হোমে তো আমরা এসি ইউজ করি তাই আমি ডিসি নিয়ে অত ভাবিনি। আমি ডিসি যেরকম আছে থাক, আমি শুধু এসিটাকে ফিল্টার করেছি।
Actually, nowadays whatever the home appliances are there, তোমরা যদি দেখো একটু রিসেন্ট ট্রেন্ডস যদি দেখো যে আমাদের সব ডিভাইসই কিন্তু অ্যাকচুয়ালি এখন চলে এসেছে ডিসির। তুমি যদি দেখো টিভি, যেটা অ্যাকচুয়ালি হোমে সব থেকে বাড়িতে সব থেকে বেশি ইউজ হয়, হোয়াট এভার উই ইউজ ম্যাক্সিমাম কেসেস টিভি, it's work with now with a DC. So this smart TVs are all are now LED based TV, LCD liquid crystal based TV, so all are the work with a DC. Even light, tube light, maximum actually nowadays the old lights not available in market also, so all tube lights are now became DC, right? And the thing is that now it may be within a few days we observe that this smart fan also acquired the market. So what actually our next target, I think, hopefully you know that. So parallel system to develop, which actually collect. So whatever the voltage we receive from solar panel, is it a DC or AC? What you mention?
DC.
DC we receive, and now what happened? We need to store this DC voltage into some cells. Otherwise, we can't able to use it because these values are not uniform. So we need to store somewhere. Then we convert it, and then we can use it. And due to this conversions, we lost lots of voltages. Obviously, conversion obviously takes some effects, makes some effects. So and this 20, if it's possible, if 24 DC is enough, 5-volt DC is enough, why we go for this 230-volt AC and then again convert, because all are converted again into DC. So the thing is that now the things that all the things are means now research is going on there, think that how it make a parallel things, a separate supply home connectivity, if it's possible or not, that go with that again this 24-volt DC. But this actually a long distance communication is not possible using this. That actually checking the sustainability of that. Right. So this is another way. So solar. So
দেখুন যদি আমি ডিসি নিয়ে ভাবতাম তাহলে আমি এখান থেকে মানে ইনভার্টার এই যে ইউনিভার্সাল ব্রিজ এর আগেই আমি ডিসিটা বার করে সেটাকে আরো মানে সেটা নিয়ে ভাবিনি আমি অ্যাকচুয়ালি ওই জন্য করিনি আমার এই প্রজেক্টটার মেইন টার্গেট
actually whenever you use a solar, first you need to store the voltage into somewhere, means you need to use a battery first, then only you can able to use properly, because otherwise you can't able to use it, because if voltage is fluctuated, if you directly connect with any device, the device voltage is fluctuated and this device damaged. So this is the issue.
মানে একটা ব্যাটারি করা উচিত ছিল
Exactly. So this actually okay, whatever you write means make not an issue, but take it a different way next time. Okay, that's fine. So so group number 6, I think there. So otherwise your projects and everything is very good, no issue. So group number 6.
Thank you, sir.
Yes, sir.
Yeah, so who want to present?
Alphonse will present.
Yes, sir. স্যার যেটা মিউট নেই সেটা
মিউট নেই, ঠিক আছে দেখছি। একটা তো করেছি, ওটা কি না অন্যটা?
ওকে স্যার শেয়ার করেছি, আমি শেয়ার করেছি।
হয়ে গেছে? Can I start?
Yeah.
So, good afternoon, everyone. I am Orko Mukhopadhyay. We are passing BTech in Electrical Engineering from Matlab Technology. So, our group next day, Arpon. Our group members are Arpon Sen, Orko Mukhopadhyay, Orko Bosu, Devashish Acharya, Pallavi Kumari. And our project is amplitude modulation with coding and simulation using Matlab. On the page.
So let's start. Let's start this this amplitude modulation.
Amplitude modulation. Amplitude modulation is a modulation technique used in electronic communication, and most commonly for transmitting messages with a radio wave. In amplitude modulation, the amplitude of the carrier wave is varied in proportional to that of the message signal, such as an audio signal. This technique contrasts with angle modulation, in which either the frequency of the carrier wave is varied as frequency modulation, or its phase, as in phase modulation. And it was the earliest modulation method used in transmitting audio in radio broadcast for radio waves. And it remained it was developed during the first quarter of the 20th century. The original form of the amplitude modulation is sometimes called double sideband amplitude modulation because the sideband method produced sideband on either side of the carrier frequency. It uses band-swatch filters to eliminate one of the sidebands and possibility the carrier signal, which improves the ratio of message power to total transmission power, reduces power handling requirements of line repeaters. Next page. The amplitude remains in many form of communication in addition like broadcasting, shortwave radio, two-way radios, VHF, air cap radio, fusion band radio, and also in modern computer. And next, the rest of the part will continue the Orphan by
So some of cases amplitude modulation. So amplitude modulation in the very important technology in this modern time, and this is cases the modulation amplitude modulation just of the aim and earliest modulation method is transmitting informations of the radio and technical device in 20th century, and this is the Landel, Dimmour, and Regeland Fessenden, and this is where the conducting this experiment using the radio telephone in 1900. So after successful this attempts the modulations technique established using the electronic communication. This is the part of the and the historical part of the amplitude of the modulations. But this is some of the main of the principle is the sum of the vary of the signal and message, and this message is carry of the carrier signal, and this message is obviously carry signal and carry wave is cannot be um, and carry information is also very high frequency. So some of the type of the amplitude modulations. So these are the double sideband and surprise carrier modulations and single sideband modulations and vestigial sideband modulation. And so different type of the modulation type, analog modulation and digital modulations. And this is AM amplitude modulation, FM frequency modulation, phase modulation, and sometimes digital modulations is kind of amplitude shift kind and frequency shift kind and phase shift kind and amplitude phase shift kind and quadratic amplitude modulation. This is of the type of the amplitude of the modulation. The next slide. So this is amplitude modulation is the mathematical tool, and this is the describe of the modulation. Actually, this amplitude modulation done on the electronical device, and this is called of the modulator. But modulation signal contain only for information, not so carry of the frequency and that case. This also some of the several name masses. This is called message signal, input signal, bandpass signal, modulating signal, intelligence signal, information and bearing of the signal. And that kind of the this is of the carry of the this important of the your message in some of the radio wave is useful. And yes, so that of the this is of the mathematical part. It is peak amplitude baseband signal, and in this case is the angular frequency modulating signal and modulating frequency. And this is part of the mathematical tool of the amplitude modulations. So next slide. So this is the real life exam. This is bandside signal. This is some kind of voice, audio, music, video, and computer data is very important use for this signal. So some of the mathematical tool is here, and this is the carrier signal is very high frequency is, and this is the main part in this, and the signal is one to another place to carry this of the signal. So this is the part of the your mathematical structure. So So the your mathematical tool. And next slide. So that is here this very important output result. This aim full waveform, and this is kind of the mathematical year result. This is this is the carry, and this is the upper side band, and this is the lower side band, and this is a resultant amplitude modulation signal. This is the actually this signal cross to one to another place. This signal, and this is the signal is both combination and the moduling signal and carry signal both only flow of the one to another place. So this is the part of the mathematical parts. And so here next slide. Okay. This is the amplitude modulation Matlab using this code. This is your coding function and coding side how to develop the coding purpose and develop your signal processing respective code. This is your fixed value, this amplitude 5 and frequency 2000, and that case is your coding part, and this is create a modeling signal. And second part is the carrier signal coding part, and this is of the some equations, and this case is some plot and grade on, and this is your whole structure, and this the coding parts in this amplitude modulations. And your next slide is this is the actual part your modulation coding part. And your next slide. Yes, this is the total actually output in the coding of the result, and this and the how to code and data Matlab how to develop in coding, and this user for the Matlab, and it is the your huge and efficiently signal, and this is of the both of the resulting signal across this crossing the one to another place. So next slide is the your schematic part. This is of the your circuit diagram of the amplitude modulation system. So this is the carrier signal, and this is the message signal, and this is carry of the product is the this is your waveform, and this is the this the scope is measure the carrier signal, and this also oscilloscope is measured in the message signal, and this total output message signal is the measure the output scope. So this is your total your circuit diagram. And next slide is okay, and this is the your input result. This is how to your vary of the first of the carrier signal, and this is the see this amplitude is the 5 and frequency is the 50, and this is your input result, and this is of the vary, and several time is 50 100 frequency, and several frequency is crossed to another two place. And long distance signal processing is very important, depend of the frequency. So next slide is the message signal. So this is of the result and input result of the message signal. Message signal is very important important your amplitude frequency, because your main part of the informations about this of the signal. So any information is very important of the Wi-Fi system, mobile data system, computing system, and any system is very important of the message signal. So message signal very important of this case. So this is of the your first result input result in message signal. And then is next slide. This is your graph. This is the message signal. This is the measure of the outputs system and output result is your total graph. And this is of the vary of the time, which time you use for some you result, and this time experiment is case of the 10 seconds. This is of the 10 seconds graph is used to plot. So this is of the several time is very important your time period, because time period is very important your any signal any processing, how to your range, how to your frequency of the time very important is the message signal in this case. So that case is the next presented. This is your carrier signal. This is very high frequency, and this frequency carried the message signal. And this is very important of this signal, because these very long distance, very large distance carry of this message and any informations, that is very important in this case. So this is your graphical system and graphical result, output result measured. This is of the oscilloscope, and this is depend on the time at 10 seconds. So this is the carrier signal, and that is the next slide is yes. This is the very important result in the output. It is total result in this amplitude modulation signal, and this signal is total both of carry and message in flow of the resulting signal that carry to once to another place. So this is almostly both of signal and carry informations about that, and this is the output result, and this is the some next tab. Okay, this is of the advantage and disadvantage. Amplitude modulation is easier to implement, and the advantage is when it comes to power use to not efficient. And that case, the advantage of the modulations this case is demodulations can be done using few of component on the circuit, and the advantage is it's required is very high bandwidth, and that is the equivalent to that highest radio frequency. And that case is advantage is the modulations, and this is the receive use to aim is very cheap, and the advantage is noise of interference very highly noticeable in this case. That's your next slide. Okay, that is your applications, and this is a very important on any signal is processing cases. Analytic system is very important is your application. First of your application broadcast and transmissions. So aim used to broadcasting transmissions over of the short, medium, and long wave band, and since wave band, and since AM is the easily demodulated radio received for the amplitude and modulations are therefore either capable in manufacturers, and this is an AR band radio of example. So that case is AM is used for VHF transmissions. Is many airborne applications such as the ground air and communications or two-way radio link in the ground and staff and personnel. And that is example of next is single sideband. Amplitude modulations is the
Yes,
information
one thing.
used for
Yes, who actually present? Please let me your name.
Orpon Sen.
Orpon, the very good things you are discussing, these very good points you are actually discussing, but these all things you implemented. I think these all things are not implemented. DSB, single sideband, subsys carrier, these are the things that we are not discussing here in your project, right? It's not a part of your project.
Yes,
right?
that's not.
So these are the parts. So you may skip these parts, right? Right, you may
Yes,
skip
sir,
that
yes,
part. I mean, whatever the things you already cover in your project relevant, that things you only need to cover, not all the things whatever available in your slides, right? So just check it and skip the unnecessary parts, right?
Sir, the next will be continued by our group mate Orko Prabhu.
Okay. No issue.
অর্ক আছে? হ্যালো, অর্ক বলবে এখন? অর্ক?
হ্যাঁ উনি।
অর্ক বলবি? Hello. Okay. In that case is your applications and this is of the modulation system, and this modulation not for this is of the broadcaster system here, because these are a lot of the very information case is the satellite communication system, and very modern technology is very important in this satellite communications, and that is your very important role about. And that case is any information in satellite used for mobile data and computer data in any data system is create a signaling processing system. So in that case, this is the end of my slide. So thank you so much. Thank you. So
Okay. Good one. So the thing is that it's very good that whatever the tasks I provide you, I encourage you to go with. I just inform you, please go with the amplitude modulation, and you go with that. Your team go with that and complete it successfully. So this is a very good, and you actually go with a very good presentations also. But the thing is that, can you tell me? So you're discussing about the modulation signals and lots of things. So can you tell me the voice? What actually the kind of signal it is? Voice, is it an analog signal or digital signal? So what is the human voice? Is it an analog signal or digital signal? Guess it.
human
Yeah.
actually I think it's analog
Yes.
signal.
Exactly. So
and
okay, you. Yeah.
ওটা যখন স্পিকার থেকে হবে ওটা তখন ডিজিটাল হবে ডিজিটাল
Cano provision, why we need this module? So when we convert it, so in that time modulation and this different of techniques are required, right? So why you go with this long speech, right? That's fine. So good one. So I think all of you now go with the things, and all of you just already complete their presentation. So now I request just this sessions, actually this 6G sessions actually conducted by Ardent Computing Private Limited. It's a training in organizations, and we share a link, YouTube link we shared. You may go with that link and subscribe with us. We have a lots of details are there. Lots of technical sessions are there available in YouTube channel. You may visit it and you may follow it. Right. So we conduct all the topics we covered for engineering, electrical, electronics, and computer science. So you may visit this channel. I shared the link through chat window. You may go with that. And another things I want to inform you, examination link now active. So if you check your, I also shared that examination link also for you, online exam. This is a clear exam is there, so that's available to online. But before going to online examination, that link I also shared with you. Before going with that, please provide your attendance, right?
Hello,
And
sir.
then yes
বলছি স্যার এক্সামের মধ্যে যে সেমিস্টারটা আছে ওটা 5th দেব না 6th? নাও উই আর পারসুইং ইন 6th, আর এইটা আমরা যে
তোমাদের এখানে মনে হয় 5th করা আছে, 5th দেবে, 5th দেবে। এখানে তোমার 5th লেখা আছে তোমাদের।
ওকে থ্যাংক ইউ স্যার।
So everyone please give exam, but before going to exam please provide your attendance. Others join.
হ্যালো স্যার।
হ্যাঁ বলো।
স্যার বলছি এখানে ওই ব্যাচ আইডি বলে একটা লেখা আছে, ওটা কি নিজের নামটা দেবো?
ব্যাচ আইডি তোমাদের তো কোনো ব্যাচ আইডি তো এখানে ক্রিয়েট করো, ওখানে দেখো ব্ল্যাঙ্ক রাখো। ম্যান্ডেটরি কি ওটা?
নাম্বার, হ্যাঁ ম্যান্ডেটরি স্যার। পাশে ব্র্যাকেটে লেখা আছে প্লিজ রেফার টু দ্য হোয়াটসঅ্যাপ গ্রুপ নেম।
হ্যাঁ হোয়াটসঅ্যাপ গ্রুপ নেমটা লিখো, যেটা তোমাদের হোয়াটসঅ্যাপ গ্রুপ নেম রয়েছে।
ওকে।
সো আদার্স জয়েন। সো এখনই শুরু করো না এক্সাম, এটা কমপ্লিট করে দিই অ্যাটেন্ডেন্সটা, ঠিক আছে? তারপরে শুরু করো। আদার্স জয়েন।
অসুবিধা হবে?
প্রেজেন্ট স্যার।
না হলে যদি অ্যাটেন্ডেন্স না দাও তাহলে মুশকিল হবে না। আমান শাও না, ওটা 30 মিনিটের।
প্রেজেন্ট স্যার।
অনুভব মুখার্জি
প্রেজেন্ট।
অর্ক মুখোপাধ্যায় অর্কপ্রভ বাসু। Group number 6, no one is there. Orpon Sen.
Yes sir.
Devashish Acharya.
Yes sir, present.
Pallavi Kumari.
Sir, Nilashish Kundu present.
Okay, Nilashish Kundu present. Pallavi Kumari absent. Rakesh Tiwari.
Present sir.
Sayantan Datto. সায়ন্তন দত্ত।
স্যার ও স্যার আমাদের গ্রুপে ছিল, ও ও অ্যাবসেন্ট আছে, ও মিসিং।
মিসিং মানে
ও ও- ওর সাথে কন্ট্যাক্ট করতে পারিনি।
ও আচ্ছা আচ্ছা, মিসিং বলে মানে তো ঠিক আছে ঠিক আছে। সোহম মিত্র।
Present sir. Present sir.
ওকে। সোনু কুমার প্রসাদ।
প্রেজেন্ট স্যার।
সৌম্য চক্রবর্তী।
Present sir.
সুবর্ণা পাল।
Present sir.
শুভম ঘোষ।
প্রেজেন্ট স্যার।
শুভময় মন্ডল।
Present sir. Present sir.
সুরজ কুমার সাউ।
Present sir.
স্বাগতম কুমার পান।
Present sir.
তম্রদীপ সিনহা।
Present sir.
তরিত্র ব্যানার্জি।
Yes, sir.
আকাশ বিশ্বাস। আকাশ বিশ্বাস। আকাশ বিশ্বাস অ্যাবসেন্ট।
Yes, না প্রেজেন্ট আছে স্যার।
আরিফ হোসেন।
Present sir.
আরিফ হোসেন। গৈরিক দত্ত। গৈরিক দত্ত।
Present sir.
হরিয়াব্র কোলে।
প্রেজেন্ট স্যার।
মোহাম্মদ ইজাজ আহমেদ। মোহাম্মদ ইজাজ আহমেদ। মৃন্ময় ঘোষ। মৃন্ময়
Yes, sir.
ঘোষ।
Yes, sir.
প্রিয়াঙ্কা সরকার। প্রিয়াঙ্কা সরকার। সম্পদ পাল।
Yes, sir.
সম্পদ পাল। সায়ন্তন দে।
Yes, sir.
সায়ক সরকার।
Yes sir.
সৌম্য পালুই।
Yes sir. Present.
Okay. So, okay. So, Akash also present, right? Akash. আকাশ বিশ্বাস।
মুখোপাধ্যায় দিয়েছেন প্রথম থেকে 4 নম্বর।
কি নাম?
আকাশ বিশ্বাস।
অর্ক মুখোপাধ্যায়।
অর্ক মুখোপাধ্যায়। অর্ক মুখোপাধ্যায় আছে, প্রেজেন্ট আছে। অর্ক মুখোপাধ্যায় অ্যাবসেন্ট আছে। অর্ক মুখোপাধ্যায় কি রেসপন্স করনি তো? আর কেউ আছে? অর্ক প্রভ।
ছিল না।
অর্ক প্রভ।
ও প্রেজেন্ট আছে স্যার।
Hello. Okay. So that's all from my sides. Thank you for your patience and attending this 6 days long sessions, and hope for your best wishes for your future. So please complete your exam, and that's all. Please complete your exam by 4:30. That's a request, and we conclude it here. If you have any further queries and questions, you may contact through groups or call me. Thank you. Thank you, everyone. Bye.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you sir.
Yeah.
Thank you sir. Thank you sir.
Yeah.
Thank you sir.